That is the sport of luge. 3D printing, additive manufacturing, rapid prototyping, whatever you want to call it, sort of brought to a very fast level. That is the sexy sport of luge. I'm Jon Owen, Technical Director for USA Luge. I'm involved in trying to take any idea we can and bring it to the sled. Basically, this all started, I've been involved in the sport since 1982, so I've been around quite a while. And I was wandering the trade show floor at IMTS, the big trade show in Chicago, a couple of years ago. Ran into some folks from Stratasys dealing with 3D printing. We were trying to find some solutions to some problems, and this is what has basically brought me here today. So the sport of luge, what you just saw on the screen, that's luge. That's what everybody sees on TV. However, for me, this is what I see luge as. I'm sort of one of those Matrix kind of guys, okay? As the sled's coming down the hill, everybody sees flashy suits and funny helmets and funny shoes, and I see all kinds of numbers dribbling down through everything. Because to me, I'm now in the side of the engineering of it, of designing the sleds. Now, the sport of luge was the first sport timed to the thousandths of a second. As a rough idea, the snap of a finger, I've been told the sound of that is about a 1/100th of a second. And so we had timed a 1,000th of a second. Everything matters that we do on the sled. Every wrinkle, every piece of performance, every piece of training matters for the sled. And so a lot of what we do prototyping in a wind tunnel. Now this is a two-man luge, doubles. And so that's what a lot of this talk is about. This is where we really sort of leveraged a lot of this technology of 3D printing and rapid prototyping into the sleds. And this is us in a wind tunnel in San Diego. Now that's a lot of body parts in a small little build envelope. And so this is the challenge. We don't have much to work with. The rules are pretty much, here's your box. You got to fit inside the box, but you can do a lot within that. And so that's the beauty, that's the fun of it. So you see, we have a lot of body parts, trying to fit all together. And remember, gaps matter. Aerodynamics is what the name of the game is. So here you see, I've sort of highlighted the front part there. It's sort of a very organic shape, a very organic place. And to look at it better, this is the flexibility. This is where rapid prototyping comes into play. It has to fit. Any air gap matters in time, but at the same time, the sled is moving at 80 miles an hour down the track. It's flexing, it's moving. You've got these body parts fitting in it, so it's got to actually be able to work for the athlete at the same time. And so what we have going on is we have to try to design this. Now, the coaches know what they want. The coaches can see it, but they're not the best at CAD designing. And in fact, in our situation, CAD really doesn't work very well. Because as most of you know, who are in here, probably everybody here has played with CAD, I play with CAD, it's a line, you do an arc, maybe if you're really good, you do some splines in there, and then you mirror it over and everything is nice and symmetrical and perfect and it looks like it came off a computer because it did. However, the human body does not come off a computer. It is very asymmetrical. Things are very organic in the human body, and CAD just is not a very good platform for trying to do that. We do use a lot of CAD, but it's usually after the fact. So our coaches will make by hand, they'll do some prototyping, they'll have a basic part, a little Bondo here, a little foam there, sanding, they'll see it, they'll try the athlete on and say, that's what I want. And so we take that and put it in a wind tunnel, see if the design is good. If it's good, then that's great. We can move forward with it. However, the problem in the past has been that traditional mold making, the old polyester molds and those kinds of things, working with the gel coats, it's very labor intensive and it's cost intensive as well. It takes a long time to make a mold, and if you're trying to make for that organic shape, it's very difficult to release out of a mold, and so you end up with these multi-part molds, so that you can pull things out. And that's a challenge. What that led to is basically one size fits all. Okay? Each team is a little different. One guy's leg is a little bigger, somebody's a little taller, a little longer. And so what we had was one size sort of fit all. It was sort of good, sort of not good, and that's what we went with. And that was leading to a problem. Incoming new technologies. All right, this is how sleds have been built basically since we started using composites probably in the early 80s, late 70s. Okay? Technology really hadn't moved forward. Come to the modern age. Now the coaches can make those shapes. They can try it out on the athlete. We can put it in a wind tunnel, see if it works. Then we just turn it right around, throw it on a 3D scanner, scan the part kicks right over. This is where CAD can come in. You can clean it up a little bit, all right? So you can make those organic shapes. You can do those things. And then you throw it out to a printer. It used to take us months, probably 4 or 5 months to go from a concept to a part. With 3D printing, 3D scanning, we are now turning things around within a matter of weeks. And when you have such a small time to build and design, because we're in the off season. Our season ends in April, and we're back on ice. The team right now today is sitting in Lillehammer, Norway on ice. And so we have a very small window in between in which to turn these ideas around, take the lessons learned, and move it forward. And so we're able to take these shapes and then turn it into molds. In this case, this is a mold for the bottom pan of a double sled. And when we started doing this, the process was moving along so fast. And this is the first time we'd done it. First time Stratasys had worked with Luge. First time Luge had tried doing anything 3D scanning, 3D printing, sort of in that direction for mold making, that we decided that we could probably throw a few extra things in. So now instead of having to make multiple molds, we're like, well, why don't we cut it and leaf it, like my grandmother's dining room table, right, with a leaf in it. So now we're actually making adjustable molds to be able to fit the teams in. If somebody's a little taller, a little shorter, we can fit them in, and that's really bumped us up as well. However, getting back to the original point, this crazy sort of front part up there, this was the problem. This is where the multi-pieces of a mold needed to be released in order to make a sled. And this is what caught my eye several years ago at IMTS. Stratasys was working with it's a sacrificial molding. So it's a washout. I think they called it ST130 or some product name. Last time I did this presentation, I found out what the ST stood for, and that was basically sacrificial tooling. Who would have thought ST would have stood for something so obvious? And so here's that front nose cone that we were just looking for on the sled. This is all sacrificial. The coaches make it. They scan it. We throw it to a printer. They print it, bring it back to me, and I can do the composite wrap on it. So you can see all those shapes. Okay, that's a hard mold to release. So we can bring it in. We can do the wrap on it. Then we send it back. It washes out. We get our completely hollow part. And lo and behold, within probably 3 weeks, in the first time ever trying to do this, we ended up with the part on the sled ready to go. And normally, again, going back, it was months to get this done in the old traditional polyester mold making, hand making, that type of methodology. So this is where the rapid prototyping and advanced materials such as the sacrificial moldings, those kinds of things are coming into play for us. And so this is the double sled that we did with that. That's the nose cone. There are other parts as well. If you look on the front here, remember the front, the legs. This is where you drive the sled. Driving is good. Okay, steering is good. Control is good. Parents like to know that we can stop. You can stop at the bottom when you run out of speed. But for the athletes, driving is what we like to do. So here's the front part, and these are actually 3D printed. And again, it's because that contact point. Everybody's legs are a little bit different. Everybody's contact points are a little bit different. And so this is what we're doing with 3D printing. And then if the coaches say, oh, we need to make a change, then we can throw it into CAD, and we can move it and manipulate it. But you can see from a lot of, again, the organic shapes there, it's really hard to design this on CAD. But you can make it, scan it, and then manipulate it on the computer. And so that's where we're doing a lot of this. And so you can see we can move it in. The coaches can look and say, oh, yeah, no, maybe 1.5 centimeters isn't right. Maybe we need to go 2 centimeters. And so we can just keep working with them until they see what they want, compared to an old model, and we can move things forward in this direction. Again, speeds things up, and it also opens up new potentials for materials. Once you start manufacturing in this printed variety, it then opens you up to other potential tooling opportunities, bladder moldings, these kinds of things, because you can make the molds that much quicker, that much easier. And also by moving into this, we've discovered that we're moving into is that once you get it on the computer, it's then really easy to throw it into FEA modeling. So now almost the entire sled is designed and functioned with FEA modeling, so that we can play with strengths, we can play with all of those really cool tools that the engineers do. I don't have those tools. I don't have the math brain or the patience to sit there and do that. But we sit there every week, and they feed them back to me and tell me what's good and what's not good. So that's a lot of where we go. Now, in wrapping up, there's another thing, personalization. It's one thing to print things in white or cream ABS all day long, but it gets really boring. Color is really cool. And so this is a point where this was going into the Olympics. This is a single sled. That piece that the big arrow is pointing at, that's actually, yes, it's a cover, but it's an important part that holds an athlete in place. If you can imagine going down the track at 80, or for the men, 94 miles an hour has been our peak speed, you might want to stay in place on the sled so that you can steer it. And so that little crotch piece actually holds you in the right position on the sled, so that you're in the right spot. And it's a 3D printed part. It's basic cover. It's a basic position holder. But we figure, it's the Olympics. Let's spandangle it up a little bit, make things a little colorful. So employing some polyjet technology from Stratasys, we sort of put our Olympic Americana on it and just created that part because, at the end of the day, just a gray 3D printed part is really sort of boring, especially if you're going to be on the world stage. So that's why, and we're going more and more into the 3D printing colors as well on different parts of the sled. Just why? Because you can. And if you can, why not do it? And that is basically, that's, in a nutshell, that is the story of US Luge and what we're doing. That's the story as we head into the last games at Pyeongchang. It came in about a year and a half going into the games. And so that is all the technology that we, in about 16 months, took, employed, and actually put on the track in Pyeongchang. And it worked. Our doubles times from where our doubles team were in 2014 to where they were toward the podium in 2018, we cut that deficit in half. And again, half to us was about 3/100ths of a second. So 3/100ths of a second to us is an eternity. We moved the bar that much closer, employing these technologies in a matter of 16 months before the games and getting it on. We're now kicking back. We're now gearing up toward Beijing in 4 years, and we have these technologies now on the plate we've played with. There's a lot we're doing. I could not tell you because it's one of those I'd probably have to kill y'all if I told you what we were doing. But we're employing a lot more of this technology throughout the sleds, and Beijing is going to be really exciting, and I can hardly wait to come back in 4 years and tell you what we had done to beat the world in 4 years, because I can't tell you now, otherwise they'd be doing it too. And that's the end of what US Luge is doing.